Today we're going to learn about triangles. The sum of the angles of a triangle is 180 degrees. A triangle is a type of polygon. Polygons, if you remember, are figures that are created by line segments connected at their ends. So a polygon can be anything that has line segments that, as long as they connect to each other, it's valid. So this would be, of course, a hexagon here, although a sloppy one. How do we prove that a triangle adds up to 180 degrees? Well, this triangle here has 81 degrees, 28 degrees, and 71 degrees. If you added it up, of course, it would be 180 degrees. However, how can we prove that visually? Surprisingly enough, I duplicated this triangle 3 times, and if you were to put all the separate angles next to each other, then you'd realize that it creates a straight line. And this line can be drawn as seen here. And a straight line is representative of 180 degrees. To show you that I used all 3 types of angles, we have 81 here, 71 is here since I flipped it over, and the 28 is here. 28 is here. So we have all 3 of these angles lined up and it makes a straight line. That proves that all 3 angles of a triangle adds up to 180 degrees. So now we can start solving some problems. If we were to solve for this variable a here, how would we figure out the degrees of a? Well, right triangles have a special property in that one of the angles is 90 degrees exactly. And we know it's 90 degrees by the little marking in the bottom left corner of the triangle. So we already know this is 90, and we know the other angle is 34, so we can just simply take 180 and subtract 90 and 34, and we're going to get our answer, and it's going to be 56. So A is equal to 56 degrees. How about this triangle here? How we solve for B and C? Well, we have one angle given to us, 46 degrees, and we have to solve for B and C. Well, C here is a supplementary problem in that C plus 122 we know is 180, since this makes a straight line. So we have 180 minus 122 is going to be equal to C. C is equal to 58 degrees. So now, in order to solve for B, we simply need to take 180 and subtract 46 and 58, for we get B is equal to 76 degrees. Now we have all the angles figured out. Finally, I want to show you some common triangles that you'll come across. The first one is an acute triangle. An acute triangle, all 3 of the sides are acute angles, and acute angles are less than 90 degrees. So since we know a 90-degree angle looks like this, we can tell that each of the angles here, 1, 2, 3 angles, all of them are less than 90 degrees. Next, we have a right triangle, where one of the angles makes a right angle. And a right angle, of course, is 90 degrees. And you can tell that this angle is the same as what I drew up here. The other 2 angles can be whatever they want. But again, these other 2 angles here, they also add up to 90 degrees, since a triangle is 180. And 90 plus 90 is 180, of course. Then we have the obtuse triangle, where one of the angles is greater than 90 degrees. So this is the angle that's greater than 90 degrees. The other 2 angles combined are going to be less than 90 degrees, since the obtuse angle takes up most of the 180 degrees. Next, we have the equilateral triangle, where all 3 sides and angles are equal in measure. And since the triangle is 180 degrees combined, that means each of the angles is going to be 60 degrees exactly, because 60 times 3 is 180. Next, we have the isosceles triangle, where 2 of the angles are the same and the third one is not. And lastly, we have the scalene triangle, where all 3 angles are not equal in measure. So equilateral has 3 sides equal, isosceles has 2, scalene has none. And we have the acute right and obtuse triangle here.